talking about this week? Does anyone remember? Material science is when we make brand new materials that have never been made before. We test out those new materials because we want to observe material properties. So that's going to be our big word for this week, material properties. And we're going to learn 6 different kinds of material properties, okay? So once we have a new material, we're making a new material, we have to test it. We have to understand what its properties are. Is it hard? Is it soft? Is it rubbery? Is it does it freeze? Does it get too hot? What happens when we use it in different ways? Because we're going to use this material to make something, whether that's a bowl or a plate or an umbrella or a toy. We have to make sure that it is the right material for the job, which is also why we research materials so that we can choose the best material for a job. So that's what material scientists do. Often they get to do this first thing where they make new materials, which is really cool. So we're going to learn these 6 material properties, all right? The first one is durability or strength. And this is how strong something is. So we all kind of have an idea for that already. So for this one, we're going to test it by tearing the material. If we can tear it, we're going to say it's not very strong. If we can't tear it, we're going to say it's very strong. Then we have flexibility. And flexibility is what happens when I bend this. Can I bend it? Does it bend? Does it get stuck in a bend? Does it stay the same? Does it break when I try to bend it? And hardness. So we do a special kind of test in science where we take something really hard, something like this, and we scrape it against different materials to tell us if it's hard or not. If this coin can scratch it, it's probably pretty hard. If the coin doesn't really do anything to it, it's probably pretty soft. Or it's so hard the coin can't scratch it, but I don't think that's the case today. It's made out of clear plastic, that's the material. And because it's clear plastic, you can see me through it, right? So if you can see me through it, you can see your hand through it. If light goes through it, it's transparent. If instead you can't see through it, it's something like this orange paper. This isn't transparent, right? You can't see through it. If I put it up, you can't see it. So transparent, you can see through it. Not transparent, you can't see through it. Then we're going to learn about density. And density is kind of complicated, so we're going to make it really simple today. And that's just, we're going to test density based off of if something floats or sinks in water. Got it? And water resistance is the very last thing that we'll test. And we're going to test it at the same time that we test density. And it's going to tell us, does this material absorb water? Does it fall apart in water? Or does water just roll off of it, right? So think about if you're outside in the rain. If you have an umbrella, the water just kind of rolls off of it, right? And I'm going to start with our metal washer, which is this one. Sorry, there we go. So this metal washer, that's the first one I'm going to test. And the first thing we're going to try and do is bend it or tear it and test how strong it is and test that its hardness. Can I bend it? Can I break it? Is it flexible? Can I tear it? I can't. So I'm going to say that it is very strong. So I'm going to give it, let's see, 3 check marks because it's very strong under strength. It is not very flexible. So I'm going to give it an X. And I'm going to give it, let's say, another 3 check marks for hardness. We'll use fewer check marks if they're not as hard or not as strong. Well, we can see through the circle, right? But we can't actually see through the metal. So, and if I pull it over, sorry, you can't really see that. But if I hold it over my paper, you can see it casts a shadow. So I'm going to say this isn't transparent. So I'm going to give it a big X for transparent. We'll do the rubber band. Can you tear it? Is it stretchy? Can you bend it? Yeah. So what about for strength? Do you think it's stronger than metal? No, I don't think so either. Let's try our test. So if it's soft, I won't see anything happen. And if it's hard, I might see some marks left over. So when I scrape it, well, I don't really see anything. And to be honest, we can see rubber. We can feel it. It's pretty soft. So I'm going to say that it's soft. It's not hard. So I'm going to put an X under hardness. It's just not hard. Now, transparency. Do you think the rubber is see-through? Does it cast a shadow? No, it's not see-through. Yes, it casts a shadow, so it's not transparent. And again, right now to show you. So this Play-Doh, let's see, what happens when I tear it? Oh, well, I can tear the Play-Doh. The Play-Doh is not very strong, right? We can tear it apart all day. Is it flexible? Can we stretch it out? It's not as flexible as the rubber, but it's more flexible than the metal, right? We can bend it, we can shape it. So I would say it's flexible. Now, what about hardness?
Let's see what happens when I try to scrape it with a metal washer. Well, it kind of just gets stuck to my washer, doesn't it?
Let Mr. Kyle take over. He is Mr. Kyle Russell. He's a graduate student, a PhD student, just like Miss Maya at USC, and he studies and works with material science. So I'm going to let him take it away from there.
My name is Kyle, and I'm currently a PhD student at the University of Southern California, and I study material science. So today, I'm going to tell you a little bit about what material science is and how I use it to work on the different projects that I'm currently working on. Field that's called engineering is sometime in middle school, I had a teacher who had a fake leg. It almost looked like a robotic leg. And I would ask him about it. It was made out of plastic and steel and carbon fiber. And I played with toys like Legos and Bionicles at the time. And I just thought, oh, this leg looks so cool. It looks just like all the action figures that I play with and the TV shows that I see, like Terminator. I would ask him, like, does it make you run faster, jump higher? Is your fake leg stronger than your real leg? And he could take it off and pass it around to us. I thought it was so cool. And the fancy name for that is called prosthetic engineering. So the big question kind of comes to us is, well, what gets you excited? And for me, the answer to that was space travel. I loved everything that had to do with rockets and space, going to the moon and Mars and even further. And one way to do that would be to go study, well, rocket science. That just sounds so awesome. So that directed me a little bit more towards the research route. And that kind of led me to the small scale. And if you can understand their structure, then you can change the properties of the material at a large scale. So a great example of this is comparing the lead in our pencils to diamonds. Lead in our pencils are made out of sheets of carbon atoms. And if you were to take a pencil and push it against a table, the lead kind of breaks apart and turns into this black powder. And yet it's the exact same material as what diamonds are. And diamonds are the hardest material on Earth. So what's the difference between this pencil lead that breaks apart just by pushing it a little bit against a hard surface, and diamonds, these super hard, shiny rocks that we pull out of the ground? Well, the only difference is the structuring of them at the atomic scale. And depending on their structure, you can get wildly different properties. So this is a great example of material science in our day-to-day lives. Specifically work with? Well, I work with these tiny, tiny, super thin coatings of metal. It's almost like paint. But just to give a sense of how thin these coatings are, if you were to take a single strand of human hair and cut it up into 1,000 pieces, the materials that I work with are as thick as one of those tiny, tiny thousandth of a slice of a hair. So that's how small of the materials that I'm working with on a day-to-day basis. I change the structure of those thin coatings, and then I measure their properties. I put them in hot. I'm structuring the atoms and the structure of these metals to make these joints a lot stronger. So these rovers can go over boulders and into ditches, and we don't have to worry about certain components on them breaking, because then we can't repair them, and then the rover is basically dead. We can't do much with it. So our goal, or this project, is to make these joints stronger by changing the structure of the atoms. And here's a super cool image that I wanted to show you guys. So this is actual image that I captured of atoms. So these are actual building blocks of matter that we were just talking about. So here, all these tiny little white dots is an individual atom. And we can see this touch on a day-to-day basis. This is how the atoms actually look inside of everything, which I find super, super cool.
Mr. Kyle, I'm going to interrupt you again, just because that's such a...
What kind of got me interested in pursuing research in the first place, and science in general, was rocketry. And so I'm still working on rockets. I work in a club here at USC, and we build rockets and launch them. And so here there's an image on the left of me and a team of us. This isn't to play this, and if you guys can get sound, give me a thumbs up.
5, 4, 3, 2, 1, ignition.
Our group is able to do this is by utilizing a certain material. So again, even rockets heavily utilize material science. And the materials that we use to actually make the rockets themselves are called carbon fiber. And again, this kind of relates back to the pencil lead I was talking about and the diamonds. Pencil lead and diamonds are made of carbon atoms. Well, so is this carbon fiber. The difference between all of these materials is how they're structured at the tiny, tiny, tiny scale. We in this rocket group take almost what looks like yarn of carbon thread, this carbon fiber, and we wrap it around a metal tube, and then we can slide off this kind of hollow cylinder, and that's the case of our rocket. And then we fill it up with propellant and we ignite it. And we need a material